Test, test.
That's it?
See, I'm not an engineer, but I get by.
You got that part, okay.
Test, test. All righty.
All right.
Good afternoon. Now, see the big flaw? All of you who want to sit close to the door, you're far from the screen. Those of you who want to sit in the back rows and drive a computer, you're going to run out of power in about 2 hours. This is part of our clever plan to make you sit in the front rows. So there are power ports in the first 3 or 4 rows and none after that. Good afternoon. I'm Allison Silverstein. I'm the project manager for the North American Synchro Initiative, and it is a great pleasure to be welcoming you all here. And I want to start by thanking Vahid Madani and Damir Novosel and Ralph and Herb from Cisco and everyone else who came up with the great idea of holding a tutorial on 61850-90-5. It's going to be a really important topic and a really good afternoon, and I thank them for organizing this and all of you for being part of it. I want to cover a couple of details, all important. The most important things you need to know are the bathrooms and the emergency exits. The bathrooms go out this doorway and down the hall to where you came out, either up the escalator or out the elevators, and the bathrooms are in a little lobby right outside there before you get to the elevators. The other important thing is emergency exits. If you go out this door, there are 2 emergency exits, one in that corner and one right over. So you're hard-pressed not to find a set of stairs immediately obvious if you go out this door. For those of you on this side of the room, if you go out that door and turn to your left, that's the service hallway, but there's a set of stairs close by that you can go down to exit the building. How many of you have signed this piece of paper, which is a video release form? Excellent. Okay, now let's embarrass. How many people of you have not signed it? Mark. Anyone else? Okay, Mark, as a speaker, you in particular need to sign this puppy. This is a reminder that thanks to Professor Miliopoulos and his students at Georgia Tech, this session is going to be videotaped, which is something we wish we had done for a number of our other superb lectures and workshops. And so we are lucky enough to have this videotaped, and it will be edited slightly. If you say anything really stupid, we're going to leave that in. But if I say anything stupid, that will be edited out, and it will be put on YouTube for a waiting world to access and learn more about 61850. And this says that you understand that it's going to be videotaped, and you understand that the material that's going to be presented is copyrighted, and that you won't object later on when you show up on YouTube, or actually since they're going to videotape mostly the speaker, and the slides will be posted. So the most likely that you're going to get on is your left shoulder or your disembodied voice asking a question. But by signing this, you are giving us permission to include that little tiny portion of you within the videotape online for posterity. So we thank you for that. If you have not signed this and were too chicken to put your name up, the hand up, these will be outside. Please sign them. What else do I need to tell you about? Power strips. Registering for this workshop or tutorial today does not mean that you are registered for the NASPI working group meeting tomorrow. So if you did not register for the NASPI work group meeting and you intend to be here for that as well, please go online to the NERC or NASPI website, find that registration opportunity, or be prepared to pay through the nose tomorrow morning. Well, you'll pay through the nose either way, whether you do it in real time tomorrow morning or online. But that is everything I needed to tell you. Thank you so much for coming. It is my great pleasure to introduce Vahid Madani of PG&E. Okay, and for Vahid and the other speakers, this microphone is a backup for the videotaping. So you have to talk into this and carry this along. So we'll put this in your pocket.
Thank you. Thank you, Allison. Welcome to the IEC 61850 tutorial. As Allison mentioned, we really have a great set of speakers. It's a well-coordinated effort. We hope you enjoy it. There are some ground rules. I'll go through the ground rules. And there's a little bit of an introduction as to how this thing came about. But at the last NASPI meeting, we had several presentations on, let's call it, particularly for this community, we do a lot of work with the synchro phasers. So there were several presentations and efforts related to the TCP, UDP data exchange and so on. And then the idea was fostered, and again, thanks to Herb and Ralph from Cisco, that let's maybe put together a tutorial, an all-day tutorial. We knew all-day tutorial is going to be a little bit strain on people, as well as having travels and so on. So PSTT was tasked to put this thing together, and here we are. Now, for some reason, my it's not advancing. I don't know if it's. Do we have a? I need your help. It finally responded. Do we have a remote for that? Okay. The objective of today's sessions are benefits and impact of the 61850, so we'll cover that. Understanding of technology behind IEC 61850, life cycle impact, integration with other standards and interoperability. There are several installations, examples of North America as well as international, and these examples are going to be covered by different speakers. So we do appreciate if you see some resemblance. You may feel like they're overlap topics, but they're really the key, the heart of the examples. And then deployment success factors, challenges, and deployment roadmaps. That's the first thing. So these are the overall objectives. Here is the outline. So we'll have a little bit of a brief history, and these are the speakers, and this matches with what's been published, so you have a copy which brought you here. My colleague, Damir Novosal, will be the moderator of the session. We are allowing 1 to 2 clarification questions. Some of your questions may or may not be clarifications, so the speakers may request that you hold a question until we have a panel session. Myself and again, Damir Novosal will take notes of the questions that come up in case we are deferring them to the panel sessions. We do have a very aggressive agenda. We're hoping that we can cover that. Again, you'll see the speakers' names. And a couple of slides. Yeah, it actually required me to do this a couple times before it allowed me. So. It's me doing it, yeah, not you.
How's she doing,
I can bring mine, it's quick. It won't hold up. We'll bring it later. For now, we'll just use the cursor here. It's okay. Yeah. I will bring my replace. Okay. Why, right? That's the why. Why? For several reasons, but I can share with you what happens at where I work, Pacific Gas and Electric. We started with, technology was at one time Modbus, then came along DNP, and then came along Synchro phasers. Now let's do this with C37118. There's a lot of flavors there, and people are really looking for one standard that encompasses. I get a lot of feedback from our people that it's really, particularly when you get into production level type systems, when you get into systems that are not tolerant of errors, tolerant of missing data. Okay, now you require real-time, pretty much 24/7 staff to respond to these. And for us, we're an electric company. We like to use the technology, but at the end of the day, reliability is the number one. okay, and operation of the system is number 2. So it's not the Modbuses or the DNPs or the C37s or for that. So can we get through standardization? Can we get into one model that can allow us to bring everything to the enterprise level? But the bottom line is, this is just too expensive and complex, okay? How did this thing originated? You can see there was an EPRI project, UCA2, the international goal, and then experience with some of the IEC standards. So that's where 61850 was formed. Okay. So it's a integration of several really initiatives and efforts within the industry. Why is this thing real? I've made this a slide several presentations, but so this may be more of a personal opinion anyways, but it's really driven by the power companies to meet a need, okay? It finally sees a promised land, okay? And we're making this thing more and more perfection every day, okay? It works and it's in the market. Fits and supports today's power system technical and business drives, and it makes an easy business case, one size. Okay. Networking dominates the utility landscape. I mean, we're pretty much all of us know that. Nothing that I have here is news to you, right? It may be time for a paradigm shift. I used to say, if you're not on board, get on board. But at some point, you will really have to face this challenge, particularly if you're a major power producer in a transmission as well as distribution system within a part of a larger grid. So how do I bring this data into an enterprise level? At this point, I would like to turn this over to Ron Ferguson. Again, if you can please follow the agenda that's part of the handouts that you had. I saw several of you have it. So.
Great. Okay, thank you, Vahid. Can you hear me okay?
No, you need to use both mics.
Oh, both mics? Oh, okay. This is recording.
That is only feeding the videotape.
Got it.
So use this one.
Okay, thanks. Get the technology up here figured out, we'll be all set.
For some reason, even this one.
I guess I'm going to stand here anyways because of this mic,
Yeah.
so yeah.
I think that's what happened.
Okay. Okay, so for, you'll see on the agenda for the tutorial, the next two modules are the origin and history, and then a summary of the benefits. And so we're just going to cover those topics, and I just want to acknowledge, and I'm going to try as much as I can to refer to a number of the individuals that are contributing here that have been involved with 61850 for many, many years, and some have actually written the components of the standard and have been very involved for I mean, we're going on many, many years now. So anyways, just a recognition of the significance of the potential for 61850 in a lot of ways, and we'll get into some detail of that. 61850 was recognized by the NIST activity, and I won't get into that too much, by the Smart Grid Interoperability Panel as one of their first batch of standards. And that's a very forward-thinking activity and group, but just wanted to highlight that. Okay, so the initial focus for Edition 1 was substation automation. And if you've got the documents, you've seen some literature from going years back, you'll notice that. But in Edition 2, the focus broadened significantly to much more general T&D automation. and getting into also hydro applications and so on and so forth. So the recognition of the value of this has been very significant, and it continues to broaden in its scope as a result of that. 61850 supports both what we would call traditional protection and control type applications. So we aren't losing anything, of course. There's a new way of doing things, but we're not losing the functionality, but we are adding significant capability going forward. Now, what comes with that, of course, is there's a bit of an increase in capability and services, which means a little more complex, but the capability is very significant. And in the long term, and Vahid mentioned this, there's a vision behind all of this, and one of the aspects of the vision there's a lot of aspects to it. One aspect is this ability in the long term, through a number of the services that are inherent, to support enterprise-wide access to that data. So the long-term vision is we come along with a new device. I'm way oversimplifying it, okay? But we are actually able to connect it into the network, and that device, through publish subscribe, the data will be available to databases throughout the system, including at the enterprise level. So significantly impacting and benefiting not just the substation work and engineering associated with that, but across the whole system. So it's a very big story when we start to look at it that way. This is a significant oversimplification. I've got another diagram here in a minute of what we're talking about at the substation level, where we've got a SCADA system at some remote location or multiple enterprise users, a substation host, or what it might be, practically speaking, a PC. We have two buses in a fully deployed 61850 substation. Generally, right now in North America, we're talking station bus only, where the traditional data and the non-operational data will be conveyed. And then we have the intelligent electronic devices between those. And then we have a process bus. And a process bus is the higher performance bus for measurement data. And the principle is measure it once, one device, okay, digitize the data at that point, and then broadcast it to all those devices. So we have one current transformer, one potential transformer, and the idea is that those measurements are available, at least currently within the substation, on a gigabit network. Here's a little more detail showing what we're talking about. We've got the users at the station level, and technical services is another way of saying that the enterprise users and the SCADA system and so on that are using data, including the non-functional, the non-operational data, such as maybe transformer measurements or could be DFR records, that kind of thing. We have bay level here, which is at our station bus. So here are the relay devices and other measurement, other types of devices. I don't want to say measurement at this point, but other types of intelligent devices. And then the process interface here, which is basically, this could be called merging units that take sampled data and digitize it and make it available. So when we talk about sampled measured values, the measurements we're talking about are down at this level here. Okay. There's the control center. Okay, so I won't get into this into too much detail because you're going to hear a lot more about it here going forward with the other speakers, but these are the 10 primary parts of the core 61850 standard set. There are other technical reports and other guidelines and other things that are being developed you'll hear more about, but this is the core set. The one thing that you'll notice right away is this is not like a normal protocol standard in that it goes way beyond what we might call the bits and bytes definitions of a protocol. Basic principles, glossary, general requirements. We get into part 4, which is system and project management. And so there is actually some significant guidance that's available in this standard to help us with process change and help us with process improvement. And when we get right down to it and you talk to utilities that are doing this, and why are you doing this? You know, what are the major benefits? You could summarize it to be significant process improvement for the utility. Streamlining engineering activity significantly and really driving cost out, not on the first one, but on subsequent. So on a production basis, driving significant cost out. Then we get into communication performance requirements, system configuration. So we have substation configuration language, SCL, and that is an XML type format, and it is defined and described in part 6. And then we get into more of the services aspects, where we have the services are defined in part 7, the mapping of those services to MMS, which originates from the manufacturing area, and Ethernet, sample measured values and mapping to Ethernet are part 9, and then conformance testing, which is a very important aspect, is part 10. I like this diagram, one of the key messages here, and I'm not going to get into the individual details. I just talked about Part 7 being services, and Part 8, which is the services mapping. SC is the specific communications service mapping, which is Part 8. This is illustrating that we are basically digitizing or virtualizing the real world. So we're showing the real world here, and we're showing the virtualization, LNs or logical nodes, a digital representation of the real world. That's what we're talking about, is object modeling. That's one of the key aspects of this technology. It allows us to virtualize what's out there and be able to have a standard definition for these models across the whole industry. Now we're talking worldwide. And so inherently we have an interoperability capability that comes just from that. Not completely, but that is a key aspect of it. And then I talked about configuration, the configuration capability in the lower part there. Okay, so the history. The original work was sponsored by EPRI. And we're going back to the 90s. And the initial early work was implemented by, as I said, under EPRI contract, GE and KEMA. And the initial document was called RP 3599, which then became UCA1 in 1990. And at that point, there was no TCP/IP. Okay, many projects, many pilot projects. I was with GE at the time. Everybody was doing pilot projects on this. Okay, but unfortunately, you don't know there's a 2 coming at that point. You think it's the 1, right? Well, it turned out to be 1.0 out of future editions. But anyways, so we had then we had AEP, and here's an example of utility that really stepped up and drove the initiative forward and brought a significant focus to it, and that work in conjunction with other activities led to 2.0, which then became an international standard 1550 technical report in 99. That then became the core technology going into 61850, which was released in 2003 as edition 1. EPRI at that point then also, kind of in conjunction with these other activities, included ICCP as part of the UCA suite of standards, and it is now often referred to as TASI.2 or IEC 60870-6. The UCA Users Group, International Users Group, was formed in 2003, and they have a very important role in this whole activity, and I'll get into that in a minute. And edition 2, the releases started in 2010. So all the way through this period, the IEC Working Group 10 and others are working hard. And we have then, since then, as you're aware, we have new technical reports, specifically 90-5, which was published in September. And that's a technical report. We have an additional TRs for condition monitoring, coming for communications outside the substation and with control centers, and Christoph will get into a lot more detail on where that's all at, as also he will talk about new standards for DER, modeling for hydro, wind, distribution automation is coming, and vehicle charging. So you can see that this is becoming a very broad effort covering a lot of different types of data and applications for the utility industry. We also have activities for mapping. And so, to facilitate moving forward from where we are in the industry, in Europe specifically, 60870-5-104, which is sort of like a network version of DNP. They have similar roots. And then we have 1815 or DNP in North America, and we're working on a mapping right now. And Christoph and others in the room are active in working with us on that. I chair the working group with the IEEE for that activity. So that not only do we have this huge future and very broad, but we're also putting in place some of the tools to move forward. And then lastly, the cybersecurity requirements are very comprehensive, and they're included in a companion standard 62351. So this summarizes what I've just said with very few words. Nice graphic. UCA 2.0 migrated forward to 61850 in this kind of time frame, and then that was the very beginning of it, and then published in edition 1 in 2003, like I said earlier. To Vahid's point of hundreds of protocols, I've lived this pain myself. It was Substations Committee with the IEEE. When we selected DNP, which is one of the options that's out there, we had 131 protocols that we evaluated. And this is back about 10, 15 years ago. And we were able to get it down at that point to 2 standards. So that's significant progress. And so we want to avoid this debate of are these things competing and so on. This is an extremely good news story. We're getting it down to very, very few options here. And we select based on requirements. It's really relatively simple. So the users group, I just mentioned, founded in 2003. A lot of different subgroups and activities associated with this group. We have a technical oversight committee. We have the SIM, Common Information Model subcommittee. And you'll hear more about SIM. 1 minute, okay. And we have the 61850 user group subcommittee, the Open Smart Grid subcommittee, harmonization, technical publications, and then the testing subcommittee, which is very, very active. Okay, I've just got a very short time here that's left, so I'm just going to go through the benefits quickly. I think I got a bit of a late start. I think I did, yeah. So we have the benefits associated with each of the primary stakeholders. We have the decision maker at the utility, and he's looking at costs, and he's looking at engineering efficiency, and we're going to talk about that in a few minutes here in terms of process improvement. Then we have the utility engineer. He's also looking at process improvements, but he's looking for tools, and it's the tools that will enable him to achieve those process improvements, and it's the technology that 61850 supports in terms of services that enable those tools. And so it builds up from the capability of the protocol itself. Of course, we have the regulator that's looking at cost-benefit ratio, and then the vendor. The vendors are very innovative when they have a set of technologies like this that they can build on to develop new products and solutions. So I'm going to go through this fairly quickly, but basically, why all the excitement? Well, the excitement is coming from the technology capabilities of the standard. So first thing is we've got the consensus definition of object models for power system devices, and I mentioned that earlier. It plays out in terms of what we call logical nodes for different elements of a device. A logical device might be a relay. It'll have many logical nodes in that device, or defined as part of that device. Self-description. Now we have the capability of an object, therefore a device, being able to describe itself as it joins onto a network. And you will be able to establish publish-subscribe relationships for the data that it generates and or needs. And all of this, other industries do this. This is just normal in many other industries. It's new for us. It is not new for a lot of the other industries that we are familiar with, like communications, for example, and manufacturing. We have what we call fast data services. So we're going to call it GOOSE, Generic Object-Oriented Substation Event, but it's basically a very fast communication method that allows relays to share data between themselves very, very quickly and very reliably. And then transmitting data, we call that sample measured values, and Synchro phaser is one of the newest and most significant users of that kind of technology. Land-based time sync, you've heard of 1588 and 238, which is the power profile for that. Cybersecurity, substation configure language, which is a XML-based tool that allows machine-to-machine sharing of configuration data. Very, very important, and it supports auto configuration in the future. And then these technologies support this kind of automated tool set that we're talking about, and also streamlines our testing and verification. So this is what I was mentioning, GOOSE, and over the long term will allow us to replace relay-to-relay wiring, some of the most expensive cost-wise part of the infrastructure, as well as the testing and drawings and so on that goes with all of that. And there's our GOOSE. And sample measured values, this is at the process bus level, high-speed measurement of what is happening in the system, measure it once, share it across the whole system, and we are using this also for Synchro phaser measurement. So to summarize some of the key benefits, we talked about GOOSE, significant dollars, and I just wanted to share a very, very brief story working with a vice president of a large power company, RU, in North America. They have 1,000 grid substations in this company. This goes back 10 years. He was mapping out his long-term plans should they ever have to do a production-level substation automation upgrade. He didn't know anything about 61850. He just basically defined what his requirements would be to basically upgrade 200 grid substations a year, what it would take to do that, and then including the economics argument behind it. He defined 61850, all of its key elements, without even knowing what it was. And this is an engineering VP who had retired from and came back as a consultant and mapped this whole thing out. We had some amazing conversations about it, and he did it. Now they're going forward now. They haven't rolled out 200 a year in 61850, but he sort of put together the case for it. So really interesting. Enhanced services, as we've talked about, that support, for example, automatic object discovery and therefore database configuration. I'm not going to repeat myself. We talked about sample measured values and cybersecurity. Configuration file formats through the Part 6. Standard naming conventions, and all of this boils down to significant process improvement. If you did a Google on 61850, there are a lot of different boards that are out there right now, and people are posting. And a senior individual, engineering manager at a large utility represented in this room, has posted a lot of stuff on